Hello, this is Zulongye at the Computer Engineering major, and now I will demonstrate the solution of homework 7 of Ece6303. Now, question 7. Firstly, we need to calculate the expression of z. We know that n1 is a wide sense stationary, and then we can get that the expectation of n1 equals to eta1. n2 is a wide sense stationary too, so we can get the expectation of n2 equals to eta2. And then we can calculate the expectation of zt. A equals to the expectation of n1 multiply cosine omega c multiply t plus theta, and then plus n2 multiply sine omega c multiply t, and then plus theta. Now we calculate this. It equals to the expectation of n1 multiply cosine omega c t plus theta, and then plus expectation of n2 t sine omega ct plus theta. And we know that n1 and cosine is independent, so we can write this expectation of n1 and then multiply expectation of cosine omega ct plus theta, and expectation of n2, then multiply expectation of sine omega ct plus theta. And then we can replace it with this eta1 multiply 1 over 2 pi, and then is a integration from 0 to pi d theta. And then we can write cosine omega c t n plus theta. And the second term is eta2 multiply 1 over 2 pi, and then the integration from theta equals to 0 to 2 pi, and the function is sine omega ct n plus theta. And then we can calculate the result is 0. The question B, we need to find RZ and determine that whether the ZT is wide sense stationary. Firstly, we need to calculate the RZ T1, T2. It equals to the expectation of ZT1 multiply ZT2, and we can write this to the expectation of n1 t1 cosine omega c t1 plus theta, then plus n2 t1 sine omega c t1 and plus theta, and then multiply another here is n1 t2 cosine omega c t2 plus theta, and then n2 t2 sine omega c t2 and then plus theta. Here we can calculate this term together and we can get the equation is equal to the expectation of here n1 t1 cosine omega c t1 plus theta, and then multiply n1 t2 cosine omega c t2 then plus theta. And then plus expectation of n1 t1 cosine omega c t1 then plus theta, and multiply n2 t2 sine omega c t2 plus theta, and then multiply and then plus the expectation of n2 t1 sine omega c t1 plus theta, and then multiply n1 t2 cosine omega c t2 then plus theta, and the last term is expectation of n2 t1 sine omega c t1 plus theta, then n2 t2 sine omega c t2 plus theta. And then we can get it is the first term equals to Rn1 and the expectation of cosine omega c t1 plus theta cosine omega c t2 plus theta. And the second term is eta 1, eta 2, then multiply expectation of cosine omega c t1 plus theta, and then multiply sine omega c t2 plus theta. And the third term, eta 1, eta 2, then multiply expectation of sine omega c t1 plus theta cosine omega c t2 plus theta. And the last term is Rn2 multiply the expectation of sine omega c t1 plus theta, and then multiply sine omega c t2 plus theta. And then we can write it to 1/2 Rn1, then multiply 1/2 pi, and the integration of d theta from 0 to 2 pi. This is the cosine omega c t1 plus t2, and then plus 2 theta, and plus cosine omega theta. The second term, 1/2 1 over 2 pi, the same, the integration of theta sine omega c t1 plus t2, and then multiply 2 theta, and then minus sine omega c tau. The third term is 1/2 eta 1 eta 2 1 over 2 pi, the integration of theta from 0 to 2 pi, and then sine omega c t1 plus t2, and then plus 2 pi, then plus sine omega c tau. The last term is minus 1/2 Rn2, and then multiply 1 over 2 pi, the integration of these theta from 0 to 2 pi, then cosine omega c t1 plus t2, and then plus 2 theta, then minus cosine omega c tau, and we calculate and get the answer. It is 1/2 Rn1 plus Rn2 cosine omega c tau equals to Rz tau. Therefore, Z is the Y-sense stationary, and the question C, we need to find Rz0. It equals to 1/2 Rn1 0, then plus Rn2 0, and we can get the answer. It is 1/2 the expectation of n1 square, and then plus the expectation of n2 square. And that's all. Thank you.